Okay, let's quickly check. Are we live, guys? Let me know if you are able to hear me. Just drop a quick yes or no in the chat. Everyone, I'll also quickly just check if we are live. Just a second. Da-da-da. Yep, looks like we are live. Looks like we are live. Good to go. Okay, are you able to hear me properly? Is everyone able to hear me properly? Okay. So, hello everyone. I believe I am audible to everybody, right? So in today's session, what we are going to do is we are going to actually talk about internals of WebRTC, right? We are going to try to understand the internal architectural details, that how exactly overall web architecture works in terms of WebRTC. If you have a WebRTC application, if you are empowering a WebRTC application, what exactly happens behind the scenes? I did a live session on Monday where we talked about a very high level, very uber overview of WebRTC, like almost just a bare minimum, just the simple, I would say, terminologies we introduce. But in this session, we are going to actually see that how exactly WebRTC works and how exactly internals of different components of WebRTC works. Why do you need turn servers, stun servers? What are these terminologies altogether? Everything we are going to talk about. So this session is going to be extremely important if you want to understand about the fact that how exactly WebRTC works, right? After this session, I believe most of your questions around internals of WebRTC, how it works, why do you need any specific thing around in WebRTC will be clear to everybody. Is that point making sense to everyone? Just drop a quick yes or no in the chat. Make sense, everyone? Just say yes or no. In case you have any questions, feel free to ask. Just ping your question in the chat. I'll be happy to answer that. Okay. Cool. Let's technically start. So what do we know already about WebRTC? I'll just give you a quick introduction, like in case somebody was not able to attend the last lecture. I'll give you a quick introduction about WebRTC. Okay. So you can say that WebRTC is kind of like a peer-to-peer connection, which internally uses UDP, user datagram protocol. So on the on the transport layer, just a second. Right, it uses the user datagram protocol. Okay, if you see something like WebSockets internally uses TCP, that is transmission control protocol, right? If it is using UDP, that means it's relatively faster, but it is less reliable altogether, right? This is what we know about WebRTC. Now what we have to understand is how exactly, if an application is working on WebRTC, how exactly it works. This is something that we have to keep in mind. Okay, and what you can understand about WebRTC is that it's very good for applications like video and audio calling. If you want to prepare a video audio calling kind of like an app, right? Because here we need performance, we don't need reliability altogether too much, right? Then you can definitely use WebRTC altogether. Okay, and you can assume that like most of the big applications like Google Meet, Zoom, all of these applications internally are heavily relying on WebRTC. Okay, so let's start talking about how exactly WebRTC work. Now in order to understand WebRTC, you need to have understanding of a few things. Okay, so there is something called as NAT. There is something called as NAT. It stands for network address translation. Okay, okay, network address translation. Now what is this network address translation? I believe everybody knows that at this point of time currently we have two main standards for IP addresses. We have IPv4 and IPv6. Can I say that there are two main type of IP addresses that are actually available? So whenever you get a new internet connection, right, either you will be allocated some kind of IPv4 or IPv6 address. Why IPv6 was actually introduced? IPv6 was introduced because there are limited number of IPv4 combinations that you can build. Okay, what is the problem with IPv4? There is a limited number of IPv4 combinations that we can have, right? I believe everybody knows about this. Okay. And in order to rectify this issue, you can start issuing IPv6. Okay. But if you remember, or if you have seen, most of the time currently as well, whenever you get an internet connection, you are still allocated some kind of an IPv4 address only. But do you understand that if IPv4 addresses are limited, how we are able to access IPv4 addresses? Okay, just think about it. If you see any household, like in your home also, you will be having multiple devices connected to the internet. Can I say that? You'll be having a lot of devices connected to the internet, your phone, your laptops, multiple phones in your house, maybe some iPads, things like that. Okay, so and and if you want to connect to the internet, if you want to connect to the internet, the bare minimum criteria that you need to have is a public IPv4 or a public IP address, we should say. A public IP address, right? We need to have a public IP address in order to make sure that we are able to communicate to the corresponding internet. Okay. Now just think about it. IPv4 addresses are limited, and we need a public IPv4 address for connecting to the internet. And we have a lot of devices to connect to the internet. So what can happen? You can ask your internet service provider, you can ask your ISP that, hey ISP, I want public IPv4 addresses for each and every individual device at my home. This is a ask that you can put at your ISP. Now the problem with this ask is that it's not the most efficient way to distribute IPv4 address, that each and every single device that needs to connect on the internet has its own public IPv4. First thing. Second thing, it's going to be expensive because there are limited IPv4 address. If you want to block a dedicated public IPv4 address, then you have to slightly pay for it. Okay. So that's not the ideal way to go for. What happens is that generally you have something called as a router at your home, right? You have something called as a router at your home. Okay. And your devices, whatever devices you have. Okay. All of this is important to understand WebRTC. Just stay with me. All of the devices that you have at your home, for example, you have a phone, let's say you have a laptop, right? You have more, let's say you have a TV as well that is connected to the internet, so on and so forth, right? All of these devices are connected to the router. Make sense, everyone? Okay. Now, what happens is that the router is allocated a public IP address. A router is allocated a public IP address. And what router gives these devices is sort of a private IP address. Okay. Router gives these devices a private IP address. Are you guys able to get this point? So this router has a public IP address, and this router provides these devices a private IP address. Now, whenever these devices have to connect anywhere else on the internet, the connection request goes through the router, and router has the IP address, public IP address. And if these devices have to communicate within themselves, so a local network can actually communicate, right? There can be communication in a local network because this is not internet, this is a local network. So they can communicate directly because they are part of one local network. But if they have to connect to the internet, they go via the router, and the router has this public IP address associated to it. Are you guys able to get this point? Okay. Now, inside this router, you have something called as NAT, network address translation. Okay. Inside this router, you have NAT. Okay. Now just think about it. If I have to communicate somewhere on the internet, my mobile phone is having a private IP address. Can I say that? Okay. And let's say somewhere else on the internet, there is another device that wants to actually communicate with my mobile phone. So how it is going to do is, this device is going to actually communicate with my router. Are you able to get this point? Okay. This device is going to communicate with my router using the public IP address. Make sense? What is static IP? I'll talk about static IP in case you want to have clarity. It's different than this public IP. Okay. Static IP is like whenever every time you connect to the internet. So there is a question from Abhishek in the chat that is it same as static IP? No. Public IP is public and private IP is about the visibility. Static and dynamic IP is about the fact that, let's say, like when do you need a static IP? Let me talk about when do you need a static IP. Let's say you have a server. You want everybody on the internet to connect to that server. What is the bare minimum criteria for that server to fulfill? That the IP address of that server should not automatically change every time it connects to the internet. Can I say that? It should have a static IP. It should not change. So you need to allocate an IP for a very elongated period of time to a machine. That's a static IP, and that's pretty expensive. What we get is every time you connect to the internet, you get a brand new IP on your router. So it's dynamic, right? So that's less expensive. So static IP you might require in case of, let's say, if you want to set up a server or something like that. Okay, coming back. So if somebody else has to communicate with my device, they are going to communicate with my router using the public IP address of the router. Are you able to get this point? And this network address translation, this NAT, is going to actually convert this request and pass it on to the corresponding private IP address of that particular machine. Are you guys able to get this point? Drop a quick yes or no in the chat. So it's because of the NAT, we have two IP addresses. One is the public IP address associated to the router, which is visible to the outside internet. And the other being the private IP address that is allocated to each and every single device associated to the router or connected to the router. And when somebody has to actually communicate, then the router uses this NAT to actually reroute the request to the corresponding device. Are you able to get this point? Drop a quick yes or no in the chat. Okay. So you can actually read more about network address translation. Let me show you. So what you can actually do is, okay. So I'll open one more session. Okay. So you can read about NAT in routers. Okay. So you can see a network address translation, NAT, is the process of mapping an internet protocol address to another by changing the header of the IP address packet while in transit via router. This helps improve security and decrease the number of IP address an organization needs. Are you able to get this point? Okay. So if you see here, let's see. So you can see this is the router which has the NAT enabled. Your machine is in the private network associated to the router. Okay. Then other machine is communicating to this router via the internet, and this NAT is going to redirect the request to the corresponding host which is associated there. Right. So all of this is actually already defined inside the corresponding NAT. Is this point making sense to everyone? Okay. This is all important to understand the internals of WebRTC. So that's why I'm going step by step. Okay. Guys, is this point making sense? Say yes or no in the chat, everyone. Which header file? I have never done network programming. Like I did network programming once with like in my college. I don't even remember what was the library used in C++. You have to Google. Like as a full-time engineer, I don't work on the networking part much. Yeah, port is when you have the machine, on that machine to which process you want to communicate, because one process is associated to one port. It's kind of like that. Okay. Like there are different ways. For example, if you don't have a router, then ask a question to yourself, how do you get that internet? There can be a case that you might be using a mobile phone as a Wi-Fi router. Like you enable your mobile phone and turn on the Wi-Fi, or maybe using a dedicated LAN. Then whosoever is providing you that LAN will be having all of these features for you. So it's about how do you get access to the internet altogether. Make sense? Okay. Cool. Let's move ahead. Let's actually move ahead. Okay. Now, what we know about WebRTC? We know that WebRTC is kind of like a peer-to-peer connection. Okay, WebRTC is a peer-to-peer connection. That means if let's say this is one machine, this is another machine, then let's say and we have the browser clients, then these browser clients is going to communicate directly with each other. Are you able to get this point? But don't you think if I have a client and this is another client, these clients are not directly accessible on the internet? Can I say that? Do you guys think that these clients are not directly accessible on the internet because they don't have a public IP to communicate to? Can I say that? Yes or no? So this is our first hurdle. This is the first hurdle, that clients do not have a dedicated public IP. Okay. And instead, the router has it. Make sense? The router has it. Are you able to get this point? Okay. And one more problem is that as a client, this client machines, or I would say these machines who are actually connected to the router, they do not know what is the public IP address this router is actually exposing on the internet to get all of the communication working. These technically do not know that. So another hurdle is, second hurdle is that machines connected to the router don't know the public IP. The public IP altogether. Are you guys able to get this point? These are the two main hurdles that we are able to see. Is that point making sense? Okay. And what we want is, we want a direct connection between two clients. We want a direct connection between two clients. The clients don't even know what is their IP address, right? Okay. So how this communication is all going to happen? How all of this communication is actually going to happen? That is the whole theory behind WebRTC that we are going to start talking about. So now we know like why I talked about this IP address thing, because we need to first of all know that why private IP address exists, right? Why exactly private IP address exists altogether? Why not every device has a public IP address? This question can come to your head. Okay, cool. Now, when we say that WebRTC is P2P, WebRTC is P2P. P2P means peer-to-peer connection. Then you have to keep one thing in mind, that this is not a pure P2P connection. It is not a pure P2P connection. Are you guys able to get this point? Why this is not a pure P2P connection? Because in order to communicate between one client to another client, what you have to do is, you have to first of all establish a dedicated pipeline connection. In order to establish that connection, these clients C1 and C2, these clients C1 and C2 need to know a few information about each other. Okay. Sure. Thanks, Abhishek. Okay. So what we are saying is that and why is that? Why? You might be having a question, why it's not a pure peer-to-peer connection? Because for connecting two clients via WebRTC, right, we need to first exchange a few information between the clients. Are you guys able to get this point? So before we actually dedicatedly set up a direct WebRTC connection, you have to first of all follow a protocol so that some important information can be exchanged between the clients. Are you able to get this point? And still these two hurdles exist. Don't forget these two hurdles. These two hurdles still exist. But apart from these two hurdles, we have to do one more thing, that we have to establish a bunch of, I would say, handshakes and everything between the two clients altogether. Are you able to get this point? Now, what is this handshake? What is this, I would say, information that you have to send? So we send something called as SDP. What is SDP? Session description protocol. Okay. So what we send is, we send kind of like SDP packets from a one client to another client. Now you might be having a question that, okay, you send these packets, but what is SDP? Okay. So you can say that it's again one more protocol, and I believe everybody knows about protocol, right? Protocol means that in order to set up a connection, there are a few rules you have to follow, right? So those rules are defined inside these protocols. Okay. So what does a SDP message packet actually contains? It contains the following things. So a SDP packet contains the following. What does it contain? First thing, it contains the information about the description of multimedia content. What type of multimedia content is going to be shared? Description of multimedia content. Okay. Apart from that, what is the format of sending this multimedia content? Okay. If there is any encryption that is going to be done inside this multimedia content, and so on. So this SDP packet contains some important information that is relevant for this connection to establish and then follow along, right? Just think about it. You want to make a WebRTC connection to do a video audio call. So you need to first of all like confirm with the other client that, hey, I want to have a video call and audio call with you. Like, is everything okay on your end? Are you feasible with that? Are you capable of that? Like, you need to first of all get a handshake done, right? That's where this SDP comes into the picture. So what happens is that client one, any of the client, let's say we call it as client one, and this is, let's say, client two. Okay. So what client one does is, client one initiates an offer. Okay. Client one initiates an offer. Okay. It sends the offer SDP. Okay. Offer SDP contains, again, information about what multimedia content to share, encryption, format, codecs, a lot of things. Okay. And this offer SDP is sent from client 1 to client 2. Okay. Then when client 2 receives it, then client 2 actually accepts the offer. Client 2 has to actually accept the offer, and then in return, to tell client 1 that, okay, client 2 has accepted the offer, client 2 sends an answer SDP. Client 2 sends something called as an answer SDP. So again mentioning, client 1 and client 2 has to communicate through WebRTC, but they don't know a lot of information about each other. So first of all, they need to set up a handshake that, hey, client 2, I want to have a video audio call with you. So this is an offer from my side that I want to set up a video audio call with you with this format, with that codecs, so on and so forth. Now client 2 has to first of all accept it if it wants to continue, and then return an answer SDP saying that, okay, everything is a good to go from my end. Are you guys able to get this point? Okay. Cool. And after this handshake is done, what happens is that the first user who actually initiated the offer, the client one who initiated the offer, right, has to send something called as ICE candidates. Now, this is a new term for a lot of people, I believe. Has to send something called as ICE candidates. Okay. You might be thinking, what is ICE candidates? I'll talk about it. Okay. And then whatever are the ICE candidates sent by client 1 to client 2, client 2 has to accept these candidates, and then your connection is established. But you might be thinking, what is this ICE candidates, right? Everybody, what is this ICE candidates? Anyone who knows what is this ICE candidates? Okay. Now, to answer the question, what is an ICE candidate, we need to, first of all, resolve these two hurdles. So how's the story coming like? How's the story coming like? The story was that one client has to directly communicate to another client. Both doesn't have their own public IP address. So first is how to communicate with both of them if they cannot have the public IP address. Okay. Second thing, that if two clients has to communicate, like somehow they are able to figure out the IP addresses, still what is the issue? They need to set up a handshake between that. Okay, this is the type of communication I want to do. So they have to do a SDP exchange. They have to do something called as a SDP exchange. Okay. In this SDP exchange, there is a step of transferring ICE candidates. And now we don't know what is this ICE candidates coming to. And that's what we are going to answer. And let's first of all solve this particular hurdle. Are you guys able to get this point? Is everyone getting along? It's a whole story. We'll communicate with the story and things will be all done. Make sense, everyone? Okay. Just one important fact that this SDP handshake that we are doing, we cannot do it directly, right? After this handshake is done, after this SDP handshake is done, then the communication can happen directly, no problem. But to do this SDP handshake, we need an intermediate server called as the signaling server. Are you guys able to get this point? Okay. Because how client 1 and client 2 will share information if they are not connected? Just think about it. If I have to share a connection with somebody else, I need to be connected to them. Like, for example, just think about it like this. If you have to send somebody a LinkedIn message, you have to be connected on LinkedIn first, right? Currently, these clients are not connected. They are still struggling to connect. So how they will be able to share information? So for that, you need something called as a signaling server altogether. Are you guys able to get this point? Okay. And once this connection has been set up, then you do not need the signaling server altogether. Okay. Are you able to get this point? So it's kind of like an intermediary friend. So let's say there are two people and they have a common friend. So they need this common friend to first of all introduce each other. And once the common friend has introduced each other, then they can communicate directly. Are you able to get this point? Is this point making sense, guys? Okay. So we need this signaling server altogether. Okay. I'll come back to the signaling server, that if you are setting up your own WebRTC connection where you can get a signaling server from, so on and so forth. But first of all, let's come to this. Let's come to this particular hurdle. Okay. Now, let's try to understand the scenario. Just think about it. There can be a case that these two machines, which are part of the same private network, want to communicate with each other. Don't you think they can directly communicate because they are not on the internet? They're part of the local network. So connection between them can be directly happening because they both have access to each other. Can I say that? Can I say that? But generally, in a video call kind of like application, this is not the most relevant scenario. Like maybe 0.1% of the users will be there who are on the same internet and still doing a video call. Can I say that? Right? Cool. Okay. Now, what's the second scenario? What is the second scenario? Second scenario is that one user wants to connect with another user via the internet. Via the internet. Are you guys able to get this point? One user want to connect to the other user via the internet. This is like the 95% of the use case that you are going to have. Can I say that? Okay. Now the problem is that if one machine M1 wants to communicate with another machine M2 over the internet, problem is that this machine M1 doesn't know its own public IP address. Are you able to get this point? This machine only knows its private IP address because the public IP address is associated to the router. Can I say that? So this machine needs to first of all know its own public IP address, because when there will be that SDP handshake, you need to tell about your public IP address as well. Just think about it, no? Because the communication has to happen directly, but it cannot happen via the private IPs. It has to happen via the public IPs. So this machine has to tell the public IP of router to the other machine. And the same thing this machine M2 also has to do. It has to also tell the public IP address of its own router to M1. Don't you think? Let me I would say simplify the scenario for you. Remember the good old days in class 10th, 9th, when you were not having your own dedicated mobile phone. What used to happen was, if your friend has to call you, they need to call to your parents' mobile phone, and your parent used to just hand over the call to you. Do you guys remember that? And if you have to call your friend, then you also used to call their parents' mobile number. Do you remember good old days? Everybody? Okay. So your parents' mobile is actually kind of like the router. Now just think about it. If your friend has to call you and talk to you, they are going to call to your parents' mobile number, but they need to know your parents' mobile number. Who will tell them your parents' mobile number? Who is responsible to tell your friend what is the mobile number of your parent? You are responsible for that, right? Can I say that? You are responsible. Just think about it. Let's say there is a friend A and there is a friend B. Friend A has to call B, but friend A doesn't know the number of friend B's father. Then how will they call? So friend B has to tell friend A, right? Same thing here. If M2 has to communicate with M1, it needs to know the public IP. But M1 doesn't know its own public IP. Same thing with M2. Are you able to get this point? This is where the concept of stun servers come into the picture. The concept of stun servers come into the picture. What does stun stands for? Stun stands for session traversal utilities for NAT. Okay. Stun stands for session traversal utilities for NAT. Okay. Now what stun server actually allows, it allows client machines to find out their public IP. Are you able to get this point? Okay. So what happens is that, let's say there is a client machine, it has a router connected. So what will happen is, this client machine has to make a request to a stun server. So there will be some stun server. Okay. This request will go via the router to the stun server. And what stun server will return? Stun server will return the public IP address of this particular router that is enabling this client to connect to the internet. How many of you guys are able to get this point? Are able to get this point? So what happens is, your client has to make a request to this stun server. So this request will go through the router. Router has the public IP. Router will make a request to the stun server, and stun server is going to return your public IP address back to the client. Are you able to get this point? Okay. And that's why in most of the cases, stun servers are going to be extremely necessary to facilitate a WebRTC connection, because in a WebRTC connection, two clients need to communicate directly. If client 1 has to communicate to client 2, they can't communicate via private IP address. They have to communicate via the public IP address. But client 1 doesn't even know its own public address. So client 1 first go to the stun server, get its public address. Same thing for client 2. Client 2 will also go to the stun server and get its own public address, public IP address. Are you guys able to get this point? Okay. Satvik is asking a question. I believe that's a fair question. That why cannot just router give this information directly? I like a question that, like, the answer that I am able to think about is that in the current overall protocol, there might not be a direct way to fetch the IP address via the private machine, maybe due to security reasons or multiple reasons. Maybe that's why, as of now, we don't have a mechanism for that. Maybe in the latest or some new versions of the router, maybe we will get that functionality. But like with a, if you are using the old legacy systems, probably there won't be anyone. जिनी यशनी एक बहुत अच्छा यूट्यूबर 5 साल से कंपनी में काम कर रहे हैं, वो कुछ अमेजिंग प्रोडक्ट पे काम करना चाहते हैं। स्टूडेंट्स सभी यूट्यूबर को न्यूटेशन दिया है। टाइम पास, जस्ट ask them to maybe communicate if they want to collaborate on something. I'll be happy to do that. Okay. Coming back, guys, are you able to understand the use case of stun servers? Why stun servers are required? And there are some free stun servers. I talked about it in the last class as well. So you can say free stun server for WebRTC. Okay. And you can see there is a list of stun servers that you can actually use. Okay. You can use this list of stun servers. A lot of them are actually exposed by Google as well. Are you able to get this point? Now, in some cases, what happens is that the clients have a very tight security. In some cases, what can happen is that the clients can have very tight security, maybe because of the firewall or anything. Okay, maybe because of firewall or some network configuration, they can have a very tight security altogether, in which a direct communication is not possible. Are you able to get this point? Okay. There can be a 5% case where this thing can happen. Okay. So let me write about it. There can be 5% cases that may be due to firewall or something else. Okay. A direct connection between clients is not possible. There can be a case like this. Okay, due to security reasons, if you have set up the firewall in such a way that nobody can directly communicate to your client, these situations can happen. Okay. Okay. So for this, we need one more intermediate layer to relay the information. What do you mean by relay? Have you heard about relay race? In like, if you have, I'm not sure how many of you guys have heard about relay race. Okay. You can see in relay race, what happens is one person is running, having a baton in the hand. They give the baton to the other person, and then that person actually completes the race. Same thing here. If one client has to send something to the other client, they are going to give this information to this relaying layer, and this relaying layer is going to take that information to the other client, kind of like a middleman. A better version or a better word would be to use like a kind of like a middleman. And this is where the concept of turn servers come into the picture. This is where turn servers come into the picture. What does turn stands for? It stands for traversal relay, traversal using relay NAT. Okay. So what is the use case of turn servers? Okay. The use case of turn server is to bypass these kind of securities, maybe because of the firewall or because of symmetric NAT, anything, to bypass all of these restrictions and then relay the information through this particular turn server. Are you able to get this point? So what will happen is that the first peer has to communicate with the turn server, right? Create a connection with the turn server and ask the other client also to create a connection with the turn server. Okay. And then using the turn server, you are going to forward the information from one client to another client. Are you able to get this point? Now the best part is most of the turn server have a stun server already included as well. So if you're using a turn server, it can also act as your stun server as well. And a lot of time, these turn servers are also referred as relay servers. Are you able to get this point? And all of this effort we are doing just to make sure that two clients are able to communicate directly because, like without any back-end interaction altogether. Okay. All of this is happening just because of that. So in most 80 to 85% of the cases, two clients will be able to communicate directly. Just to communicate, they need the public IP address. Stun servers can give them the public IP address. In case due to firewall restriction or there is something called as symmetric NAT, due to these kind of security reasons, if two clients cannot directly relay information, like send information, you need a relaying layer that will be your turn server or your relay server. And you are going to send the information to your turn server and turn server is going to pass on that information to the other particular client. Are you guys able to get this point? But this is like for a very less number of use cases. So we have solved our problem. We have solved our problem that clients were not having the idea about their own IP address. So the stun servers are going to actually help them to understand their particular IP address. Now coming back. Now how do two clients communicate? Now client one will communicate to the stun server, get its own, what do you say, IP address. Client 2 will communicate to the stun server, get its own public IP address. Then using the signaling server for one-time setup. Signaling server is for your one-time connection setup. You offer an HTTP, client 2 accepts the offer, answers an HTTP, and then client 1 starts sending something called as the ICE candidates. Now this is where we are going to talk about the ICE candidates. Are you able to get this point? So let me just, before I talk about ICE candidates, let me draw the overall architecture properly. So this is, let's say, your client 1. Let me know, guys, if you have any questions or anything. This is your client 1. Okay. And client 1 is going to communicate to a stun server. Okay. And stun server is going to give a public IP address in response. Okay. Same thing will be done by client 2. Client 2 will also communicate with a stun server. And client 2 will also get a response back. And then using a signaling server, they are going to set up a direct connection between each other. Okay. Direct connection using signaling server only one time. You have to use the signaling server one time. And in case a direct connection is not possible, then who is going to come into the picture? The turn server is going to come into the picture, and client 1 will communicate to the turn server, and client 2 will also communicate to the turn server, and turn server will give the response back. This is the overall architecture of your WebRTC application. Okay. Yes. And in case this, okay, so somebody is asking a question. Okay, Abhishek is asking a question that, do the machine need to connect with the same stun server? No, that's not necessary. Machines can communicate with different stun servers altogether, because you just have to get your IP address, nothing more, nothing less. Okay, cool. Now the final piece of the puzzle. Okay. What is this ICE candidate? What is this ICE candidate? Are you able to get this point? Okay. What is this ICE candidate? Anyone? Now, can you see? There are three ways. Technically, there are three ways in which two clients can communicate. One way is, if both of them are in the same local network, they can communicate directly. Another way is using the stun servers. And another way is using the, another way is using stun servers and then communicate directly. Or another way is using the turn server. Are you able to get this point? So there are technically three ways to communicate, more or less. Yes or no? Yes or no, guys? Yes or no, guys? There are more or less three ways to communicate. Yes or no? So now, when you send this ICE candidate, ICE candidates contain all the details about the available methods to communicate. That, can you do a direct connection, or you need a turn server to communicate? Both of these things, or are you part of a local network, then also a direct communication is possible. What type of connection has to be done? What's the efficient way for these two clients to communicate? This piece of information is sent by this ICE candidate. Are you guys able to get this point? Drop a quick yes or no in the chat. Are you guys able to get this point? Okay, so you can read about ICE candidate. You can again say it's kind of like a data packet only, like ICE candidate WebRTC. Okay, you can see ICE candidate serves as addresses that device used to connect with each other over the internet. Now these addresses can be their direct addresses or the via the turn server. Are you able to get this point? Are you able to get this point, guys? Drop a quick yes or no in the chat. Okay, so you can read about the ICE framework. Like this is also referred as the ICE framework. Okay, you can see what does ICE stands for? Interactive Connectivity Establishment. It is a framework to allow your web browser to communicate with peers. There are many reasons why a straight connection from peer A to peer B won't work. Can you see this line? Can you read this line? There can be reasons why a peer A, a browser A cannot directly communicate to browser B. There can be reasons. I told you, firewall, symmetric net. There can be multiple reasons. In those cases, it needs to bypass firewalls that would prevent opening connections, giving you unique address if, like most situation, your device doesn't have a public IP address, and relay the data through the server if your router doesn't allow you to directly communicate with the peer. ICE use stun or turn servers to accomplish this. So this whole architecture that, okay, maybe client 1 can directly communicate to client 2, or client 1 has to communicate via turn server to client 2. This whole framework, this whole decision mechanism is part of the ICE framework, which has this ICE candidates. And you can say that these are also information that you actually send to tell the other client that, okay, hey, client 2, we are going to directly communicate, or hey, client 2, we are going to communicate via a turn server. Are you guys able to get this point? Drop a quick yes on in the chat. Is this point making sense? Say a yes or no in the chat, guys. Everyone. Now, do you understand how exact, and like WebRTC is what? Just a direct peer-to-peer connection. Like just direct two machines are just going to directly communicate with each other. Okay, two machines are going to directly communicate with each other. Now, how they will directly communicate depends on how they connect. If they connect directly, okay. If they can't connect directly, they need a turn server. But in order to connect directly or indirectly, they need their public IP address. That is given by stun server. Are you able to get this point? Again, Satvik is asking, how does it know what method to use? Again, it depends. If there is a firewall or there is a security reasons due to which your router is not allowing you a direct connection, then of course you need to go via the turn server. If there is no rules, nothing is breaking you or nothing is stopping you in between, then you can directly make a peer-to-peer connection. Are you able to get this point, guys? Everybody. I want a yes or no in the chat, guys. Okay, so WebRTC uses this ICE framework. What is ICE framework? ICE framework is this whole mechanism: stun server, turn servers, this SDP, this signaling server. This whole architecture is part of the ICE framework that WebRTC uses. Okay, now can you see this signaling server has just one task: to offer SDP and get an answer SDP for C2 and C1. So this signaling server is going to just establish the one-time connection. And after that, there can be a direct connection or there can be a connection via the turn server. Can I say that? There can be a direct connection or there can be a connection via the turn server. So we need this signaling server for one-time connection. That's why it's not a pure P2P connection, because it still needs some server interaction for one time, or it might need a turn server interaction forever. So in the last live session, I made you guys install something called as peer.js. I made you guys install something as a peer.js. Remember? So if you are setting up, let's say, your WebRTC application, your video calling application using peer.js, then peer.js is going to act as your signaling server. Are you able to get this point? Okay. And it has all the configuration and everything required to communicate to some particular stun server and everything on the top of it, right? But this is going to main core crux act as a signaling server. Is this point making sense, guys? Now, a question can come to your mind is that, okay, sir, WebRTC is a peer-to-peer connection, like client 1 can directly communicate to client 2. This is good for one-to-one video call or one-to-one audio call. But what about a group call? What about a group call, guys? Okay, Kennel says, I didn't understand signaling server. So Kennel, see, there are three servers involved. One is stun server, one is turn server, one is signaling server. What is stun server? Stun server will give you your public IP address. What is turn server? In case direct connection is not possible, then you communicate via turn server. What is signaling server? For setting up this connection, for setting up your direct connection or for setting up your indirect connection via turn, you need to offer SDP to each other. This offering of SDP happens via signaling server, because now C1 has his public IP address, C1 has the messaging format, communication format. It needs to send all of this information to C2, right? How does C2 know what is the public IP address of C1? Somebody has to send all of this information, right? So this SDP offers all of the relevant information and gets the answer SDP back. That's what signaling server is required for. It's signaling server is required for the first time setup. Satvik, all of this that I'm talking about is not with respect to Spring Boot or Node.js. It's the architecture of WebRTC. Are you able to get this point? Like you can actually check. For example, set up WebRTC with Spring Boot. You'll get some relevant articles altogether that if you want to set up a WebRTC with Spring Boot, what do you need? Okay. So let's see. You can see for a peer-to-peer connection, you need a mechanism called as signaling. Okay. You can build your own signaling server as well. Can you see? You can build your own signaling server as well. You can use some other signaling server as well. So you can just read about it. Okay. Coming back. Now, guys, just think about it. How exactly group call is going to work in case WebRTC is a direct peer-to-peer connection? Anyone? How is group call going to work in case like client 1 is going to directly communicate to client 2? But what if in a group call we need 5 people to directly communicate? How is that going to happen? Anyone? No one? Okay. So how many of you guys have heard about SFU? Okay. So in this case, there are three mechanism that we can do. One mechanism can be, let's say there is a client C1, client C2, client C3, client C4. Now, yes, Kennel, you are thinking in the right direction. If client C1, like with every WebRTC connection is a direct peer-to-peer connection. So client C1 and C2 will communicate, C1, C3 communicate. This kind of a mechanism is going to happen. What is this? This is mesh. This is mesh topology. Can I say that? That everyone is communicated to everyone and everyone relays every information to everyone. For example, if a video call is going on between all four, when C3 sends packet, C3 has to send packet to each and everyone. And everybody has to receive the packet of C3. And maybe there are parallel packets coming from other people as well. This is called as mesh connection. But we have something called as a better way, SFU, single forwarding unit. And this is a very simple and straightforward way. What is an SFU is that you maintain a central server. You maintain a central server. All the clients, can you see C1, C2, C3, C4? Now, these clients are not going to directly communicate with each other. Are you guys able to get this point? Okay. These are not going to directly send information to each other. What's going to happen is they are actually going to stream the information to this central server, and then this central server is going to forward the stream back to each and every other client. How many of you guys are able to get this point? How many of you guys are able to get this point? So there is a central server that is going to collect data from each and every single client. Okay. And then forward the data to the remaining particular clients. Are you able to get this point? Okay. So now here the direct P2P connection is not going to be between clients. It's going to be between the client and the central SFU server that you are going to have. Are you guys able to get this point? Okay. So now the client and this central SFU are going to be connected via WebRTC. Okay. They are going to be connected via WebRTC. Thanks, Abhishek. Thank you for the kind words. Okay. So when we are going to implement our application, if you remember, I started building some React part, some Node part. So we'll complete the code like today. I thought let's complete the theory in one shot. So we are also going to use our Node server as the SFU guys. We're going to use our Node server as the corresponding SFU. Are you able to get this point? Make sense, everyone? Cool. Any questions, guys? Any questions? Any questions from anyone? You can, if you have any random question, you can just quickly ask. Now, do you understand like internally how WebRTC is working? Right? Because saying that two peers are going to have a direct connection is not enough. And when we will be coding it, then also you will require this peer.js, that will be the signaling server. You will require your SFU server, right? So for that, all of these internal information you need to know. Are you able to get this point? We'll be coding it in Stack in probably in the next class. Let's set up one more class. I don't want you to bombard too much information on your head, but yeah. Okay. Cool. सर डीएस एंड जेएस का कोई स्टैंड अलोन कोर्स भी आएगा कभी फ्यूचर में इरिस्पेक्टिव ऑफ इंग्लिश हिंदी if you want a standalone DSA and JS course, we have one. We just have not listed it. You can mail us at algocamproot@gmail.com and the team can help you guys. Okay. Also, one important piece of information, everyone. I'm thinking to give this information in the start, maybe from next time. Okay. So we have launched a bunch of new courses on Algocamp. You can just go and check it out. So there is a new Stack course. There is a Spring Boot course also that is live. There is a advanced backend development in Node.js course that is live. So you can just check it out. And if you are interested in end-to-end Stack development, then you can opt in for this code. You can use the code early bird to avail some massive discounts, and these prices will start slashing. And you can check the overall curriculum. Interesting part is that this is our first English course. So that is an experiment that we are doing. We keep on doing experiments at Algocamp. So do check it out, guys. V3 nahi hongi. I just wanted to do these as live YouTube sessions as well. So that's why just for a change of mood, you can say. Okay. We'll be launching DSA in Java, but after a few months, probably. Okay. Any questions, anyone? Any questions? Okay. So if there is anyone who wants to understand architecture of WebRTC, internals of WebRTC, do share this session to them. I guess it was a no nonsense, no shit, direct to the point lecture. I'm happy with the overall execution. Otherwise, I thought there will be too many random questions might be popping up here and there. But yeah, I really overall like the execution. Yes, Kriti Kumar. I thought like the whole streaming app part we can do live as a YouTube streams. So that's why, Kriti Kumar. We'll be doing it. We'll be coding it. Don't worry. Guys, so in the next part, we'll be coding our live video calling app. I believe that's going to be interesting. Make sure you have done the basic setup of PRJS on your local machine, and you have done the basic React and the Node app setup. We are going to code it in the next class altogether. Okay. Coding is going to be straightforward. If you know basic WebSockets and if you know the internals of WebRTC, it's going to be pretty straightforward. No brainer at all. When this WebRTC can fail, so there can be security consideration where this WebRTC fails, because in that case, turn server comes into the picture. So there is still a server side interaction. Apart from that, it's not very good for like multiple peers communicating, because then you need a SFU server. Apart from that, it's UDP, so packets can drop. A lot of disadvantages are also there. Everything we are going to do, like for signaling server, we are going to use PRJS. Rest everything we are going to code. Okay, Kriti Kumar, maybe I need one more session for screen sharing then, because in the next session we'll be doing the camera sharing, and then maybe we can do screen sharing as well. There are browser APIs to relatively very easily handle screen sharing. Okay. So in SFU, this is what selective forwarding is, Irfan. That in SFU, you have this SFU server that's a central server. Whenever one client has given the information, SFU forwards it to the remaining set of servers. On larger scale, WebRTC is not used. It's not the case that on larger scale, WebRTC is not used. For example, like applications like Omegle and everything are all powered by WebRTC. It's just that, like, when you just see WebRTC, plain simple WebRTC, it's for P2P communication. But if you see complex applications like Zoom, they're not just two people communicating with each other, right? There are many people in the call. There is chat involved. There is screen sharing involved. Recording is involved. A lot of things are involved. So, of course, on top of it, you have to build a lot of things. I am not sure what Hotstar uses, right? I'm not sure about the internal architecture of what Hotstar uses for live streaming of the match. They might be using it, because what we can definitely confirm is that it's a UDP connection. So WebRTC can be a good way, but there is something called as RTMP as well. You can start reading about it as well. That can also play some part there. No problem, Kennel. I hope the work is going good. Thanks, Kriti Kumar. Thank you for that. Okay, that being said, let's wrap today's session here, guys. I hope you guys enjoyed the live stream. Let's have some chill streams as well in the coming week. I'm planning some chill streams, like maybe we can just sit back, relax, and just talk. Let's do that. Maybe some Hindi ones as well. But this was kind of like I wanted to just teach something. So I just came up and just have a quick live session. That being said, let's wrap today's session here, guys. We are going to meet soon in the next session. Till then, take care. Bye-bye. Have a really lovely week ahead and keep coding.